All right. So based on request and for the sake that we didn't treat this on the drone particular day, I'll be teaching you how to process the image. So you click on workflow, either you choose add photos or you choose add folder. So I would go with add photos. So click add photos, locate the folder where the picture is saved or where the picture is, open up the folder, and then you add all photos. You select all photos. You select all photos. I'm going to be using my project photos to do this because I actually forgot to copy the drone image, the one we did at Enugu State. So, but the one I sent to you guys are the one you're going to work with. For now, okay, after adding photos, then you go back to workflow, you go step by step, and then you click align photos. For the sake of this, for it to be very fast, I'm going to be choosing the recommended one you should be choosing is high, but I'm going to be using high and interchangeably medium. But for now, you choose high and then leave every other thing at the advanced stage. You leave it at default and then you choose okay. Allow your work to run. Usually takes time depending on your system processing speed. It takes time. This system I'm using about 16 gig RAM, and I forgot, I think it's I core 7 that I'm using, or like I core 5, I don't know. But depending on your processing speed, that is how it's going to run very fast. If it doesn't, it might even take 4 hours for you to align your photos. Yes, it might take 4 hours for you to align photo. So just allow it to work. It took me some time to process this, but for a fast system, it might take you less than 20 minutes. For a slow system, it might take you up to 4 hours. Then this is what it looks like after aligning your photos. You can explore your images. This, but is not necessarily needed now. So we'll go back to workflow. The third step is now to build dense cloud. Dense cloud is like point clouds where you get your X, Y, Z, like the height of each point or each buildings or any place in that surface area. So to build this, I will not use the high because I don't want to waste time on this. But while building yours, it is recommended that you use high or highest. I'm going to be using the medium. So I'll be using the medium, and then choose advanced, leave it at mute, every other thing leave it at default. Then you click OK and allow to run, just like that. Or rather, let me take you to low, so it's going to be very fast. Then you click OK and allow to run. You see, for this system, it's not taking so much time, but for yours, I really don't know how long it's going to take, but all depends on your processing speed. Then we go back to workflow as well and click build build mesh. Build mesh. We click the build mesh and then we choose the surface that is going to work on. We choose the dense cloud. It's going to use the dense cloud to work on. Then the surface, we leave it at 3D, and then every other thing at default, and we allow it to run. The essence of all of this is to create an auto-mosaic image. Every of these images would be one. You know why taking these drone images? It has already been configured that it's going to be at 75% overlap. So all of these image are going to be auto-mosaic to be one. So these are the steps that you're going to take for you to get your auto-mosaic image. I had to be pausing and playing so I wouldn't take much of your time, so the video will not be so long. And the progress where you're going to be looking at for your progress is this down, the down bar, not even the up bar. So this is what your build meshed image look like. This is what it looks like, and this is where you can explore. Probably when you're creating a 3D image, you can zoom in, zoom out, explore your work environment. So the next step we are going to take is to build the DEM. The DEM is you can actually build the surface area where you can build on. You can actually build on the mesh, or you build with the dense cloud. Leave your each the mine is showing resolution at 0.4, so which is okay. You can leave it at that. And then when it pops up that you have to save your work before proceeding, when this shows up, you have to go back to file and save your work to wherever or folder you're working with. After saving it, then you can come back and continue the process, build DEM. Okay, our image has been saved. Now you have to go workflow, click build DEM, and then just as we have done it before, just click OK and allow it to run. After clicking your DEM, it will pop up. We all know what DEM is now, the digital surface model, digital elevation model. That is where you get your surface heights of everywhere in your study area, both the building inclusive, the floor inclusive, surface height of everything in your study area. So the next step we are going to take is create Orthomosaic. Now the surface will be the DEM, leave everything else at default. Resolution for mine is 0.05 meter. Click OK and allow to run. So you see how simple this is. If you have a very fast system, everything just works for you, and everything just works for you, and it's so easy. Just go to the field, get your image, come back to the office or go back to your home and work it at night, and you get your automosaic image, and then you can go ahead to analyze your image. So this is our automosaic image running. It's in progress right now. I'll have to pause so that it will run. Okay, it's fast already. So this is it for our Orthomosaic image is already coming up, and sometimes it might not show. So just go to your layer and double click on Orthomosaic image, and then this is it. You zoom in to see how very clear it is. This image was acquired at 150 meter, just like the one we acquired in Enugu State at NIHS conference. So imagine if you are taking this at 50 meter, you know how very clear this would be. If it was taken at 60 meter, you know how very clear it would have been. So that is it for this. So okay, now I want to export the image. So you go to file, export DEM, and here is where you change the coordinate system you want to export in. You you don't want to export in the WGS84, you can find your national coordinate here and exporting, or probably you want to leave it at WGS84 EPGS, you leave it there and export your DEM. The same thing applies for Automos. Like there are two ways of exporting. Either you go to file and you export, or you come down to I'm coming, let me click it now. Export. This is me exporting the DEM, so I can export. And then the other way is coming down to Orthomosaic, right click, export Orthomosaic, and voila, change your coordinate system if you don't want it to be in WGS84. Then you can go ahead and export, and you have your Orthomosaic image. So after exporting, you can continue your analysis on ArcGIS or QGIS, depending on the software you're using for your analysis. So our images are being exported. This is the Orthomosaic being exported. It might take some time, like I said, depending on your processing speed, your laptop processing speed or your laptop processor speed, however the English might go. So this is it for the Orthomosaic image. It's still running, and yeah, we are done. So you can go back to opening it normally using your laptop image viewer, or you can just open up ArcGIS and import your image or drag it to the workspace. Your image will load automatically on ArcGIS. All right, so mine is taking some time. Okay, drag and drop, and this is what our drone image, our Orthomosaic image looks like on ArcGIS. And then you can continue your data analysis here. You can do an as-built survey, get your boundary, your perimeter, get coordinates, and that is it. And remember to do this so you would not forget it. I would be sending a zip folder of the image and the software whenever you have time and you would like to practice. Feel free to also ask me questions. Thank you.